right, now these are a little different. Okay, so these, yeah, they're quadratic, but it's not always going to be y greater than. We might have something else going on. Okay, so I'll do this one with you, and then, okay, why don't you guys try this one? Just pause for a second, try it. I'm not going to put any questions on there. I just want you to try it. Okay. All right, so let's look at this one. First of all, when we box it out, okay, well, first of all, I mean, before I even do that, I can tell that this is continuous because the line is connected. Okay. I have Dr. XY, right? So this is my domain and this is my range. Okay. So when I look at my domain, okay, well, first of all, when I box this out, actually, remember, you know what? I actually did my highlighting wrong up there, right? Because when there's arrows, we don't box anything, do we? We can't highlight next to an arrow. Yeah, I did that wrong. Okay, well, you won't know it because I'm gonna redo it. But yeah. So okay, so what do I have here? When I smoosh, right? I start here. So let's do my domain first. And then they're connected all the way through. So I have something that looks like that. Okay. So my x values, see how it's pointing that way? It means it's greater than. And the value it starts at is 0. It's also equal to because it's a dot there. Okay, my range. My y values start at 0. I have an arrow at the other end. So my y values look like that. Means my y value is greater than or equal to 0 also. Okay? So f of 2, again, f of x equals y. F of 2 means they gave me an x value. So when x is 2, y is 4. F of x equals 1. When x is 1, y is, well, when y is 1, x is 1. Okay? Now, why is there not a symmetrical pair? Because on this graph, we don't see the other side of the parabola. So if we don't see it on a graph, we don't use it. Okay? All right, this guy right here. This is discrete data. Okay, so in this case, because I see dots, I have discrete data. Okay? So, okay, now this one's going to be a little trickier to find my domain and range because, like, kind of having to guesstimate here. But do I have a dot on 0? Now, in this case, because it's dots, my domain is going to be a list. So I start with my fancy brackets. Do your best. Okay, do your best with the fancy brackets. I have 1, 2, 3, 4, 5, 6. Okay, well, actually, if I just push the dots down here, I think what we said was table it out, right? So let's make ourselves a table. I think that'd be easier than anything else. So I have, what is that? I'm going to estimate these. So I have 1, let's say maybe 4. It looks like 2, maybe 8. And again, I'm estimating these. They don't have to be perfect. And then I have 3. Oh, what is that? 14? God, I don't know. 4, 22, 5, 32, 6, 44. Again, I'm estimating 7, 56, 8, 74, 9, 92. Again, I'm estimating. Now, I don't think they would ever give you something like this on STAR. It would be a lot easier to tell, but still, okay. So let's just pretend that these are the right values, okay? So then for my domain, I would list my x values. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That's my domain. Those are the only values I can use, okay? For my range, oh God, 4, 8, 14, 22, 32, 44, 56, 78, 92. Okay, and that will be my values. Okay, again, we're estimating. Okay, so f of 5. Well, f of 5 means I have 5 for x. Well, when x is 5, y is 32. F of x equals 72. Well, I guess that was supposed to be 72. So y, then x is 8. Okay? And again, you know, we're estimating on this one. On a real, I wouldn't expect them to give you something like that's this crazy on a, like an actual test. Like that would be, I would be upset about that. And you would too, and you should be. Okay? All right, last one. I want you, well, I want you to try this one by yourself. Again, I'm not going to ask any questions about this one specifically because I want to see, I just want you to try it. And then we'll see if we get the same answers. Okay? All righty. So, Dr. XY, in this case, my domain, this one I can block everything out. Okay, I can block everything out because look here. I got dots. I don't have any arrows at the end, so I can block everything out. And I'm really sorry about messing that up there. I was, you know, I didn't prepare myself. I'm so sorry about that. Okay, so I can block this all out. All right. So it looks like my x values go from 1 to 5. Remember, when I block something out, I'm looking at the edges of the block. Okay, I go from 0. So my x's go. So first of all, I have continuous data because they're connected. So that means my x's look like this, and it goes from 0 to 5. Okay, 0 to 5 is going to be one of those between inequalities, so I put the x between 0 and 5, and then I put less than signs. These are dots, so they're equal also. We will practice this tomorrow. I know y'all are like, what? We will practice it. Okay, now my y values, okay, I don't think that was supposed to happen, but you know what, whatever, we'll say it did. Okay, so my y values, when I put them over here, my y values look like this, and the top value is 7. And just for our purposes, let's just say that the bottom value is 3, because I'm not trying to make this complicated. All right, it's probably like negative. It's probably like negative 3.25, but I'm not about that life. Okay, so let's just say negative 3. So that means my y values, and I always put the smallest one on the bottom, so they go from negative 3 to positive 7. And since I don't see any circles, I include those values. Okay? So I go from negative 3 to 7. Okay? Now, let's look at this function notation. Remember, f of x equals y. This time they say f of 5 equals what? Well, that means they gave me an x value. When x is 5, y, what? Oh, when x is 5, y is 7. Okay? F of x equals negative 2. So when x is negative 2, it looks like I got 2 values. Oh my, what? Okay, whatever. Okay, so x is, when, we're going to say we have 0. And let's just say 3, okay? But it's probably closer to like 2.5 or 2.75, and any of that would be okay. And we will do more of this tomorrow. Again, this video is mostly just for learning. I'll see you then.